advancement of technology dramatically reshaped several businesses, which led to the inception of big data. The concept behind data is the new oil is that just like oil, raw data isn't valuable in and of itself, but rather the value is created when it's gathered completely and accurately, connected to other relevant data, and done so in a timely manner. Hello everyone, my name is Ahmad Bitar, and today I will be presenting my thesis topic about the analysis of the critical success factors of big data implementation in the GCC manufacturing industry, supervised by Dr. Ozan. The presentation will include the following topics: introduction, research significance, research gaps and questions, research objectives, literature review analysis, and research methodology section. Many terms describe big data. However, until now, there is no unified definition of it. One of the descriptions state big data as being the upcoming management revolution, the fourth paradigm of science, and the key of sustainable innovation within an industry 4.0. Also, big data can be described as the infrastructure, technologies, tools, methods, techniques, and processes used to source, store, and analyze large volumes of data to produce actionable insights. This slide will give us a small idea about how much the world is gathering data these days. For example, between 2003 and 2013, data increased by 500 times. Can you imagine the number within 10 years span only? Moreover, the revenues from big data in general increased from $122 to $187 billion between 2015 and 2019, and so on. And this slide shows that the revenues generated from big data are increasing significantly. For example, between 2015 and 2021, the revenues from big data increased by 100%. And the pie chart shows the distribution of the revenues among all the different industries. For example, the big data revenues from the manufacturing sector contributed to around 19% of the total GDP in 2019, which illustrates the importance of this sector. To be more specific, let's look at big data in the manufacturing industry worldwide. Research done on data concluded that managing and analyzing big data efficiently and effectively is considered among the most important success factors for companies in the manufacturing field these days. This can happen upon a critical assessment of the data gathered from different sources like production equipment, sensors, enterprise resource planning systems, etc., contributing to the decision-making process. In addition to determining the variables that impact the production, observing and decreasing the risk factors, alleviating the operational efficiency, and analyzing the competition for every product, etc. So far, we have seen the importance of big data in the manufacturing sector worldwide, but what about the GCC area? Therefore, this slide shows the GDP value for the GCC countries in 2019. As shown, Saudi Arabia, Qatar, and UAE own the lion's share of the total GDP. The GCC area contributed to around $1,700 billion in 2019 only, highlighting the importance of the GCC area compared to the worldwide. Here, we also went one more step in our research to see the significance of the manufacturing industry, particularly in GCC area. For a long time, the GCC region's industrial efforts have concentrated on manufacturing to diversify the economy's revenue sources away from oil. For example, KSA GDP from the manufacturing sector increased from $58 to $99 billion between 2010 and 2019, as shown in this slide. Therefore, and due to the importance of this industry, we decided to do very extensive research on the critical success factors of big data implementation in the GCC manufacturing industry. Hence, our first step was to do an extensive literature review regarding this topic, and this is how we did it. First, a total of 110 papers were selected via digital search that are related to big data implementation. Second, upon observing the abstract and the conclusions, 80 papers were chosen. Third, upon reading the detailed review of all the papers, 60 papers were selected as being relevant to the success factors topic. Fourth, upon filtration of the results and exclusion of the duplicate papers, only 35 articles remained as final sources to extract the factors from them. Therefore, the following gaps were found in our research. First, until today, no research paper has been carried out to analyze big data implementation in the GCC manufacturing sector. Second, the papers published about the implementation of big data worldwide are limited. Third, the majority of the published papers use only qualitative approaches to analyze the success factors. Therefore, more quantitative approaches are needed. Fourth, most of the quantitative research done either look into the causal relationships or at ranking the factors, while in reality, both approaches must be made at the same time to ensure that we provide the manufacturing sector with a short and a long-term implementation plans. Hence, the following research questions will be addressed. What are the critical success factors for the adoption of big data in the GCC manufacturing industry? What are the causal relationships between the success factors? How to prioritize and rank the critical success factors? Therefore, the research objectives would be the following. First, to identify the success factors from literature review. Second, to refine and narrow them down based on experts' opinion using a qualitative tool named Delphi method. Third, to explore the causal relationship among the influencing factors and categorize them into cause-effect factors using the decision-making trial and evaluation laboratory quantitative tool named DMATEL. Fourth, to prioritize the key factors and rank them using the analytic hierarchy process quantitative tool named AHP. Considering the importance of using the technological, organizational, environmental TOE framework to adopt big data, several research studies have tackled the technology implementation based on this framework. Information systems researchers have adopted this TOE framework successfully to determine the main factors that impact the use and implementation of new technological innovations. The illustrated table shows some of the information system studies based on the adoption of the TOE framework. For example, topics related to business intelligence, big data adoption, Industry 4.0 adoption, and the Internet of Things were analyzed using the TOE framework. Therefore, our research will adopt this framework to understand big data implementation and its relevant critical success factors. This slideshow shows the roadmap for the success factors selection procedure. First, over 45 factors were chosen from the related literature. Second, similar factors were classified together to remove any repetition. Third, the factors which occurred least likely were outcasted. Last, the remaining success factors were segregated according to the TOE framework. The summary of the technological factors that were found from the extensive literature review are as the following: data quality, availability and processing, big data capabilities, security and privacy, technology infrastructure, data capability, complexity, scalability, and ease of use. The summary of the organizational success factors that were found from the extensive literature review are the following: leadership, developing big data managerial positions, organizational culture, resources management, top management support, business and information technology alignment, development of skills and training, employee engagement, organizational structure, HR capability, change of management, and maturity and readiness. While the summary for the environmental factors are as the following: customer relationship, market turbulence, supplier relationship management, competitive pressure, and government support and policies. To conclude, this diagram summarizes all of the TOE success factors combined together. The research methodology is defined as being the roadmap displaying the different research stages. As shown in this slide, our first step was to identify the success factors from the literature review. The methodology used in this paper is a mixed approach. One qualitative method named Delphi is adopted to verify and filter the data gathered from the literature. Moreover, two quantitative methods are used: the decision-making trial and evaluation laboratory DMETAL and analytic hierarchy process AHP. These methods are implemented to prioritize the factors based on their importance for implementation and tackle the cause-effect relationship among the different factors and classify them. Finally, the findings will be analyzed to create an implementation roadmap to help the GCC managers in the manufacturing industry to implement the big data successfully. In this slide, we will discuss the first method used, which is the Delphi method. The Rand Corporation first introduced the Delphi method in the late 1950s. It's defined as a systematic, iterative methodology that gathers judgments from a panel of independent experts. Two principles rule the Delphi method as follows: the anonymous findings and the independent judgment. Therefore, 12 panelists will participate in this study who have comprehensive professional experience over 5 years in the GCC manufacturing industry or among big data experts and university academics. Thus, the experts will participate in the Delphi approach to determine the most crucial critical success factors. Now, regarding the limitation of this method, it's challenging to acquire validity in the qualitative Delphi method since results will be obtained based on experts' judgments, depending on their experience, perspective, which may be considered as a bias. In this slide, we will discuss the second method used, which is the AHP method. The analytic hierarchy process AHP was defined as a decision-making practice according to Professor Thomas Satie in 1980. AHP is applied for prioritizing the success factors. It helps in developing short-term decision-making strategies. Thus, it's considered a fundamental decision-making strategy that handles the decision criteria issues and structures them into a hierarchical structure. However, it's incapable of identifying the causal relationship between these factors, which is considered a gap in this technique. Additionally, AHP fundamental assumption is that the criteria are independent, which is not practical when discussing the success factors for big data implementation. And these are the steps used in the AHP calculation. Step 1, define the goal and establish a hierarchical framework. Step 2, create surveys for pairwise comparisons. Step 3, calculate the normalized weights for each significant factor. Step 4, calculate the consistency ratio. And step 5, calculate the local weight. Step 6, calculate the global weight. And the shown tables show all the equations that will be used. Third methodology. The Geneva Research Center was the first to present the DMETAL in 1971. The main goal of DMETAL is to identify the effect and causal relation intensity between the direct and indirect variables within a complicated system through matrix calculations. Thus, it's important to use it in order to assess the success factors of big data implementation in the GCC manufacturing industry. However, the Mattel computation is based on the expertise of a team of specialists to determine the degree of impact between the variables. Hence, this is considered a limitation, since bias may occur due to the perspectives of each expert and their academic or industrial background. And these are the steps used in the Demeter calculation. Step 1, calculate the initial average matrix. Step 2, calculate the normalized matrix. Step 3, calculate the total influencing matrix. Step 4, calculate the causal parameters R and C. Step 5, create diagrammatic representation of the causal relationships. Step 6, and finally, do the data interpretation, and the shown tables show the equations that will be used. Finally, I would like to thank you all, and I will be glad to answer any questions you may have. Thank you.